Good morning children. I am Vijayalakshmi working as maths teacher at GBHS Thirumalgiri. Today we are going to learn about the relation between zeros and coefficients of quadratic polynomials. The general form of a quadratic polynomial is ax square plus bx plus c. The greatest power of the variable is 2. That is, there are two terms, x square and x term. So as x square is a degree of 2, we say that the degree of the polynomial is 2. As the degree is 2, it can have at most 2 zeros. So the maximum number of zeros will be 2. These zeros are denoted by alpha and beta and read as alpha comma beta. Now when we say the zeros of a polynomial, that is the value of the variable which makes the value of the polynomial to be 0. So there is a relation between zeros and coefficients of a quadratic polynomial. If ax square plus bx plus c is a quadratic polynomial having zeros alpha and beta, then we have two relations. The relation 1 is alpha plus beta is equal to minus b by a. So alpha plus beta is nothing but sum of the zeros is equal to minus coefficient of x by coefficient of x square. The second relation is alpha beta is equal to c by a. Product of zeros is equal to constant by coefficient of x square. Now let us check it up with an example. Now here x square plus 3x plus 2 is a quadratic polynomial. So we are supposed to check the two conditions. So before going that, we need the two zeros. So I am factorizing x square plus 3x plus 2 and finding the zeros. So x square plus 2x plus 1x plus 2 equal to 0. So 3x I have been splitting it into 2x plus 1x. So in the first two terms x is common, so x into x plus 2 plus in the second underlined bracket we get 1 is common, so x plus 2 is equal to 0. So x plus 2 into x plus 1 equal to 0. X plus 2 equal to 0, so x is equal to minus 2 and x plus 1 equal to 0, so x is equal to minus 1. So the two zeros of the quadratic polynomial are minus 1 and minus 2. Now comparing it with the general form, a value is equal to 1, that is coefficient of x square, and the coefficient of x is 3, so b is equal to 3, and the constant is 2, so c is equal to 2. Now alpha plus beta is equal to minus b by a. So on the left hand side substitute the values for alpha and beta, and on the right hand side we substitute the values for b and a. Minus 1 plus minus 2 is equal to minus 3 by 1. So minus 3 is equal to minus 3. So your first condition is verified. Now coming to the second condition, alpha beta is equal to c by a. So minus 1 into minus 2 is equal to 2 by 1. So minus into minus we get plus, so 1 into 2 is equal to 2, and on the right hand side 2 by 1 is equal to 2. Therefore it is again verified. Now with these relations, what are the uses we are going to find? So we can say the sum and product of the zeros without knowing the zeros. So alpha plus beta we need not know. Once we know the coefficients, we can directly say what is the sum of zeros and what is the product of zeros. For example, find the sum and product of the zeros of quadratic polynomial 2x square minus 6 root 3x plus 12 equal to 0. So here a is the coefficient of x square which is equal to 2, b is equal to coefficient of x which is equal to minus 6 root 3, and c is the constant 12. So now sum of the zeros alpha plus beta is equal to minus b by a. So just substituting b value and a value. So minus 6 root 3. So one minus is from the formula and the other minus is for b by 2. So 2 3s are we get cancelled. So minus into minus we get plus. So 3 root 3. So sum of the zeros is 3 root 3. Without knowing the zeros, we can directly say what is the sum of the zeros. Similarly, product of zeros is equal to alpha beta c by a. So value of c is 12 and value of a is equal to 2. So 12 by 2 is nothing but 6. So product of zeros is alpha beta is equal to c by a, which is equal to 6. So here we did not find out the values of alpha and beta, but just by using the condition we are directly able to say what is the sum of the zeros and what is the value of the product of zeros. Now let us see the reverse case. So till now a quadratic polynomial was given to you and you have found out the values of zeros, that is alpha and beta. Then we have verified the condition of the sum of zeros and product of zeros. Now coming to the reverse process. So here zeros are given and we are going to frame the quadratic polynomial. So framing a quadratic polynomial when zeros are given. If alpha and beta are zeros, then the quadratic polynomial is given by k into x square minus alpha plus beta into x plus alpha beta. We can use this when zeros are known or sum and product of zeros are known. If zeros are known, in place of alpha and beta we substitute the values. Suppose we know the sum and product of zeros. Instead of alpha plus beta we substitute the sum of zeros, and instead of alpha beta we substitute the product of zeros. Here we can take different values for k. But generally we take the value of k so that all the coefficients of the polynomial become integers. It's just for our convenience. For example, frame the quadratic polynomial having zeros 4, 3. So here zeros are given, that is alpha is equal to 4, beta is equal to 3. So here zeros are given and we are going to find out the quadratic polynomial. So polynomial is given by k into x square minus alpha beta into x plus alpha beta, where alpha is 4 and beta is 3. We substitute these values in the polynomial. So k into x square minus, so instead of alpha I am putting 4 and instead of beta I am substituting 3. So 4 plus 3 into x plus 4 into 3. So k into x square minus 7x plus 12. As there are no fractions, we can take k is equal to 1. So x square minus 7x plus 12 is our required polynomial. Now let us see another example where we have fractions. So frame the quadratic polynomial with sum of zeros is minus 1 and product of zeros is 1 by 4. So here instead of alpha and beta they have given the values of alpha plus beta and alpha beta. So sum of zeros is minus 1. So alpha plus beta is equal to minus 1 and product of zeros is 1 by 4. So alpha beta is equal to 1 by 4. So the polynomial is given by k into x square minus alpha plus beta into x plus alpha beta. Substituting in this, instead of alpha plus beta we are taking it as minus 1 and instead of alpha beta we are substituting it as 1 by 4. So k into x square plus 1x plus 1 by 4. We can take k is equal to 4 so that the fraction part 1 by 4 can be formed into an integer. So multiplying the whole polynomial with 4. So 4x square plus 4x plus 4 into 1 by 4. So 4 get cancelled in the last term and we get 4x square plus 4x plus 1 is our required quadratic polynomial. So children, today we have found out the relation between the zeros and the coefficients of a quadratic polynomial and how to frame a quadratic polynomial when zeros are given and how to frame the quadratic polynomial when sum and product of zeros are given. So this is our summary of today's class. Thank you children.